Hello everyone, in this lecture we'll try to understand the basic concept of air pollution control. So before coming on the main topic of air pollution control, let's understand the concept of air pollution. Look at these two pictures. In one of the picture you can see that this vehicle is emitting smoke, and in another picture you can see the picture of industry. And these all industries are also polluting or also emitting smokes or harmful gases. It may be harmful gases. So in these two cases, you can see that the real composition of air is getting altered, is getting disturbed here. If you look at the real composition of air, inside the air you will find nitrogen, oxygen, argon, and nitrogen is very abundant into the atmosphere. That is, it constitutes about 78.084% of total volume of the chemicals present into the atmosphere. And second is oxygen, that is 20.94, or somewhere you also find 20.84. And argon is at the third most abundant chemical into the atmosphere, and the least one is xenon. Okay, this is important one. Now the question is, in which situation we call something as a pollution? Okay, and here we are talking about air pollution. Any kind of thing, any kind of material, it may be solid, liquid, or it may be gas, which are emitting into the atmosphere, which are entering into our atmosphere and altering the real composition of air. Okay, and that change, that alter, if that change is causing detrimental effect, very harmful effect on the human health and society, then only we call it pollution. Let's say suppose any kind of chemical change which occurs into the atmosphere, or any kind of solid, liquid, or gas enters into the atmosphere, and if that change into the atmosphere is very useful for the mankind, then we never call it pollution. If that change is causing the harmful effect on the human health and the society, or somehow it is reducing the visibility, somehow it is corroding our environment, our atmosphere, then only we call it pollution. Okay. Now look at the definition, what it says. Contamination of the atmosphere by gaseous, liquid, or solid waste, or its byproducts, that is pollution. Look at his statement, you will get more clear concept that contamination of the atmosphere by solid, liquid, or gas, or gases, liquid, solid wastes, or byproducts that can endanger life, attack materials, and reduce visibility. Okay, that is air pollution. Hope I'm clear. Now the question is that if I'm talking about control air pollution, then from where we can take steps to control pollution, controlling measures, control measures. So we need to know the sources of the pollution, from where it is emitting out. So there may be two sources of pollution. Either the source may be fixed, somewhere it is established permanently, like factories, like refineries, like power plants. The sources are fixed. We can identify that source. You can see in the picture as well. But some sources are moving, are mobile, like the buses, cars, trucks. And the picture you can see airplane, it's moving. So in this case, it's very difficult to capture the air pollutants. It becomes very difficult to capture. But in this case, it's somehow it's an easy task to capture the air pollutant. Now, either you're talking about stationary source, or we'll talk about the mobile source. In both the cases, this air pollutant may be of two types, or two different kinds of pollutants will find into the atmosphere. That is, the first it may be particulate matters. PM refers to here particulate matters, or it may be gaseous pollutant. In both the cases, in mobile case also, the pollutant may be particulate matters, or it may be gaseous pollutant. Okay. As far as PM is concerned, in this lecture mainly I will focus over the stationary source and especially the particulate matter. Now this particulate matters, what actually it is? Obviously I'm 100% clear that you might have seen particulate matters. When you travel for long distance, you can see that a few black carbon particles get deposited on your face. Okay, you can feel that by doing like this. And also when you pass a beam of light into a dark room, you can see it clearly. Okay, the dense particulate matters. So let's understand first that what is particulate matter, then we'll proceed further. You can see here, I have given 3 pictures of particulate matters. It's a bigger size, it's a finer one, it is ultra fine, it is more minute, more fine particle. And I've given here the size 10, here refers to 10 microns. Hence PM10, particulate matter 10. This is PM 2.5 microns. Microns is the size of the particulate matter, which is suspended into the atmosphere. And this is PM 0.1 microns. Now, this particulate matter are usually suspended into the atmosphere. And if I talk about the chemical composition of this particulate matter, here may be some different kind of chemicals, like there may be nitrates, there may be sulfates. Okay, it will depend upon the locality from where we are collecting the air sample. Let's say suppose we are collecting air sample from the industrial area. In that area, you can find heavy metals as well in the atmosphere, like zinc, like copper. You can find into the atmosphere. So this particulate matter is composed of solid plus liquid. Just make it clear. It is composed of solid plus liquid. Some moisture are also present into the atmosphere in the form of fine droplets. You can't see with your naked eyes, it's very difficult. Now, this particulate matter composition varies from place to place. As I have told you, that in industrial area, you can find metals, nitrates, okay, zinc, copper. You can, in some way, we can also find ions as well, sodium ion, potassium ion. But when you take the sample from the forest area, forest region, there into the atmosphere as a particulate matter, you can find water droplets along with pollen, allergens. Pollen causes allergy. It's well known, it causes asthma. You can find into the atmosphere. So the composition of particulate matter depends upon the locality from where we are capturing the air sample. Okay. Now just understand the basic concept of these 3 sizes of the particulate matters. This particulate matter, that is of PM 10 microns, if you inhale this particle, it can stick up to your throat, your lower part of the throat, which you can easily squeak it out through cough. It's very easy to just eject out from your body. It's very easy one. But this PM 2.5 microns, it can enter from nasal cavity and pass through trachea, and finally it goes to bronchus and then bronchioles, and it terminates at the alveoli. Means it can pass to the lower respiratory tract, lower part of the respiratory tract, that is alveoli. And when this PM, such a small size of particulate matter, if it enters up to your alveoli, this means it can clog the passage of air into your bloodstream. Then ultimately you will feel the symptom of breathlessness. Okay, so this may happen with PM 2.5, so it's dangerous. But this one, it's ultra fine particle, PM 0.1 micron. It can even penetrate your alveoli and can enter into the bloodstream. So it is more dangerous. So a lot of diseases are associated with this particulate matters. Mostly they are associated with the respiratory problem. It may be heart diseases. In respiratory problems, you can see COPD, chronic obstructive pulmonary disease. You might find lung cancer. Patients are suffering from lung cancers. Those who are living in the industrial areas. Okay, there may be bronchitis. There may be allergy of something. So these are the symptoms of the pollutants, the air pollutants. Okay, these are caused by the effect of air pollutants. Okay. Now see, I have given the brief, the overall, you can say the overall data about that, from which reason you can obtain these particulate matters. Okay, as a researcher or as a aspirant, if you want to collect the sample of particulate matter, that from where we will get dissolved particulate matter, then PM10 you can find near roadways. PM2.5 you can find near power plants, area which have too much power plants, industries, automobiles. And PM.1, that is ultra fine particle, you can find as well near power plants. So it's very difficult to just confine the area of particulate matter, but usually mostly we can see that these all things are found in such places. Hope I'm clear. So the same thing, it has been written here, that what is particulate matter? Definition I have written. PM is a widespread air pollutant consisting of a mixture of solid, liquid, gas. It's not gas. Solid and liquid particles suspended into the atmosphere. I have mentioned here 3 sizes that are smaller than 10 microns. It can just stick below your throat and it's very easy to spit it out from your throat. And particles smaller than 5 microns. It can reach up to the bronchial tubes, that is at the top of the lung, which I have told you. Bronchial tube, this is what? This is bronchus. This can reach up to this region. And as for PM 2.5 microns or less than that, it can penetrate even your alveoli. It can reach up to your alveoli. But the size less than 0.1 or 0.1, less than 0.1 or 0.1 can enter inside even your bloodstreams. So to understand the size of the particulate matter, look at this picture. You can get relatively more clear concept. It's a diameter of the human hair, you can see. And the diameter of the human hair is 50 to 70 microns. And you can compare it from the particulate matter, the PM10. The size of the PM10, you can compare it out. That because the size of the PM10 is 7 times, 5 to 7 times lesser than the size of the human hair. Examples are dust, pollen, molds. Okay. And the size of PM10, PM 2.5, as you can see, it's 2.5 micron. And the substances which include inside the PM 2.5, it may be pollens, organic compounds, pollen, metals, it may be there. You can get more clear picture from this view. It's a picture of fine beach sand and its size is 90 microns. So just you can imagine that how small this particulate matter is, and if it get stick to your nasal cavity or somewhere into the respiratory tract or somewhere inside the bloodstream, so it may cause very harmful effect on the health. So it's very important to capture such all things. To control these all things, to get to be safe from such all kind of pollutants, what we can do, we have few technology which mainly acts upon the stationary kind of sources of pollutant. Okay, so I have written here devices to control PM particulate matter from the stationary source, from the fixed source. It may be settling chamber, which you have to study, is in our syllabus. Second is fabric filters. Third is Venturi scrubbers. Fourth is cyclone collectors, and the last one is electrostatic precipitors. So these all equipments I have arranged it into the more efficient form. Means settling chamber is less efficient, is less effective. Fabric filter is comparatively greater. Venturi scrubber is comparatively more greater. And the most effective is last one, that is electrostatic precipitator. Okay. On what basis I am calling that it is more effective? On the basis of power, force, which we are using in the equipment. Okay. In this settling chamber, we will use gravity as a key source of power or energy to filter out the particulate matters. In a fabric filter, we'll use fabric, as this word suggests, fabric. We'll use cloths to filter the particulate matters. Okay, along with gravity. Gravity will also take part in such separation. So little advancement you can see. In this, we'll use only gravity, and this will use fibers, fabric, cloths, as well as gravity. In this Venturi scrubber, we can use the force of water along with gravity. Okay. So the thing becomes more advanced, more powerful in such equipment. But in cyclone collectors, we circulate the air around the equipment, around the instrument, to increase its inertia of the particle. Get your point? And that is why it's very easy to collect, to separate that particulate matter which is let it into the air. And last one is electrostatic precipitated, more powerful type of force energy we'll use in this case, that is voltage current, high voltage current we'll use in this electrostatic precipitated. So one by one we'll go through all the specs of the equipments. So let's start with settling chamber. Now look at this picture. It's a picture of settling chamber. As you can see, dirty air will pass through this pipe and will stay here for a few moments or few time. And the time which is expended by this dirty air into this settling chamber, this is called a residence time. And after spending few moments into this settling chamber, or you can say into the rectangular box or cylindrical box, the particulate matter into the air will get settled down into the hopper, and finally pure air will eject out from the settling chamber. So basic principles you might have understand that basic principle of in which we use in this settling chamber is gravity. Under the action of gravity, the dust particle or the particulate matters present into the air will get settled down, will descend down into the hopper, and from here we can easily collect it out. So the thing is that why it happens like this. If you look at the diagram of the settling chamber, this is inlet, the diameter is very less, but as you proceed further, the diameter drastically increases. This increase in the diameter of the settling chamber will reduce the velocity of the polluted gas which is passing through this chamber. When the velocity of the air or polluted air which is passing into the settling chamber will reduce, then ultimately the gas will, the particulate matter will start settling down into the hopper. One more thing, it's very important. When particulate matter will start settling down into the hopper, it will start settling down into the hopper only when the velocity of the gas or the polluted gas, let's say V. I'm talking when the velocity of the gas, polluted gas, let's say V, becomes equal to the settling velocity, let's say Vs, of the particulate matter, then only particulate matter will start settling down into the hopper. Okay. To give a strong basis of all the scientific evidences, we have to give mathematical evidences, some logical evidences, some logical interpretation. And that's why I'm saying like this, that when velocity of the gas, polluted gas, let's say V, becomes equal to the velocity of the settling velocity of the particulate matter, let's say Vs, if both the velocity becomes equal, then only dust particle or the particulate matters will start settling down into the hopper. Okay, this is the first case. Second, when particulate matter will start settling down, when the velocity of the particulate matter or when the velocity of the gas present into the settling chamber is flowing with a speed of 3 meters per second, then it will start settling down into the hopper. Why so? If we pass the gas from a higher velocity, then the particulate matter present into the air will not settle down into the hopper. Okay, it will not settle down. Get your point? Or it might be possible that the particulate matter which has already been settled down into the hopper will get ejected out and flow from this region. So our mission to collect the particulate matter will become fail. So a few things we have to take into consideration while filtering the particulate matters from the dirty air. So mathematically, if you want to establish the relation between this settling velocity as well as this settling velocity of particulate matter as well as the velocity of the filtered air, then we can say that if the length of this the settling chamber is L, and if its height is H, okay, and its settling velocity of the particulate matter is Vs, and velocity of the gas which we are passing into the settling chamber is V, then obviously we can say that H upon Vs is equal to L upon V. Okay, hope I'm clear. And in the same way, this can be written as Vs is equal to HV upon L. By Stokes' law, Stokes has given a very unique, very, you can say, very useful relation for the settling velocity of the particulate matter, that why it settles, on which parameter it get dependent upon. Okay. So he has given a very beautiful relation that V, a settling velocity of the particulate matter, is equal to G into rho P, density of the particulate matter, minus density of the gas, into d square upon 18 mu. Here mu is viscosity of the gas. G, understand it? Acceleration due to gravity. Okay, and after equating this both equation, you will get your final result, that is D is equal to 18 mu HV upon Lg, density of this particulate matter minus density of the gas, raised to the power 1 by 2. I mean to say, this diameter, this is diameter of what? This is diameter of particulate matter. So this diameter of the particulate matter will be filtered when we take such cases. When we take particular type of height, when we take particular type of length. But if we talk about the efficiency, that in which case this settling chamber is more efficient. So in the filtering of particles greater than 50 microns, it is more efficient. I mean to say, this settling chamber is meant to separate particulate matters greater than 50 microns. Okay. Even it can filter particles less than 50 microns, but it will take too much time, and which will also affect the efficiency of the settling chamber. So it is more efficient with the separation of particulate matter whose size is greater than 50 microns. Hope I'm clear. Now look at this first line. The settling chamber can also be called as pre-cleaners. Now the question is, why we call it pre-cleaners? The thing is that, as I have told you, that look at this picture first, this slide, that the efficiency of settling chamber is not too much high. Only it can filter particles greater than 50 microns. Okay, but in factories, you are establishing these all equipments into the factories, into the fixed sources from where the air pollutants are emitting out. Okay. Now, if we use only single equipment, then it might be possible that the minute particles which might not get separated from the air pollutant. Okay, and if you emit without separating the particulate matters from your industry, so it's a criminal offense. You can't do this. You can't just play with the life of the people. So along with settling chamber, we use one or two more equipments in series, and that's why firstly we pass the air pollutants, the dirty air from the settling chamber. Then after we can use another equipments as well, that we can use fabric filters, we can use electrostatic precipitators along with this settling chamber. So I mean to say, settling chamber we use at the first moment, so that large particle gets separated out, and the load of the next equipment which will use further, like electrostatic precipitator, will become decreased. That's why you at the first position. prior to using any kind of high equipment like electrostatic precipitors. Hope I'm clear. And that's why we call it what? Pre-cleaners. Okay. Same thing it has been written. Just go through this slide, what it has been written. It's same thing which I have already discussed. Now, working principle, as I have told you, that it will totally depend upon the gravity and its simplest one, no doubt, and its size will depend upon your requirement. It may be horizontal, it may be rectangular, okay, it may be long cylindrical. So one thing it's very important, from which equipment this settling chamber can be composed of. We can never make this settling chamber with the help of metals. No. Why so? Because the gas leaded or the gas or the substances, not gas, sorry, particulate matters present into the air, okay, may be of different form. It may be sulfates, it may be nitrates, it may be few metals which may react with further settling chambers, the chambers of the settling chamber, and may produce several type of gases, several type of secondary gases. So it's very difficult to say which type of gas will produce into the settling chamber. So to avoid this, we make settling chamber from the bricks, from the cements, to avoid such chemical reactions into the settling chamber. And finally, we get the fresh air. Okay. Not too much fresh, but a like of fresh air will find after passing the gas through settling chamber. Now, as far as its efficiency is concerned, I have already discussed this. This is more efficient when it, to separate the particles greater than 50 microns, 50 micrometer. And when we increase the residence time, when we increase the stay time of the gas into the settling chamber, automatically the efficiency will increase. Okay, and also we have to keep the velocity into consideration. I've already said that if you increase the velocity more than 3 meters per second, then it's very difficult to separate out the particulate matter suspended into the air. Okay, you have to keep the velocity less than 3 meters per second, or not less than 0.1 meter per second. Okay, it's a range. In this range, if you keep the velocity of the gas in this range, the efficiency will find at a higher rate. Get your point? And the last point is that the settling chamber are most effective in collecting large or dense particles. So obviously, the particle must be greater than 50 microns, but often fail when the chambers becomes plugged with collected dust. This is a problem. Okay, often the hopper get plugged, get blocked. It's not working properly. All the time we need to filter it out. So the basic funda behind this settling chamber is that it's a simplest one. There's no hi-fi technology used here, and we can. It's very cheap. Also, it's very. If I look at its cost, so it can be affordable by any kind of industries, any kind of power plants which has been recently been launched, recently been introduced. So it's very easy to just establish into the factories. So for this video, I will stop here, and in later on videos I will discuss about the later equipments which are used to prevent air pollution. And next we'll cover about the venturi scrubbers, and later on will come on the electrostatic precipitators. So thanks for listening to this video, and thanks for watching. Thank you so much.